Hello everyone, let's study about free oscillations. When a body capable of oscillating is displaced from its equilibrium position and then left free, it begins to oscillate with a definite frequency. This frequency is called the natural frequency of the oscillator. When a body performs oscillations with its natural frequency, then it is said to be having free oscillations. To understand this, let's take an example of a simple harmonic motion. Let's take an example of the spring mass system. Let's assume that we have a spring attached to a mass, and let this line be the reference line for this oscillations. Suppose if a force F acts on the spring and it is pulled to some extreme end, if the mass is pulled to an extreme end like this, and if it is let to oscillate, let's call this reference line as say C, this as B. So it's been pulled and left at point B. If we leave it here, it will oscillate. It will cross the point C and go to other extreme end, which we'll call as reference point D. So in this case, the mass would oscillate between the points B and the D. If we assume that the spring is placed on a surface which is frictionless, and also there is no friction anywhere in the system, then this mass would oscillate with a certain frequency and time period. The frequency F is given as 1 by 2 pi under root of K by M, where M is the mass of this object and K is called as spring constant. This is the frequency of oscillation of this spring mass system. Now this frequency with which the body oscillates on its own, that is, once the applied force is removed, once we pull to point B and remove the applied force, then this would oscillate between points B and then D. Such frequency, which happens without the presence of an external force, is called as free oscillations. That is, there is no need of any external force to make it oscillate. And the frequency with which it oscillates is called as natural frequency of the body. So this is called as free oscillations. Now this oscillation occurs due to the elastic forces and inertia of the system. That is, in this case, the reason that the mass is being pulled towards the mean position is because of the restoring force in the spring. So what is given here is, says that those oscillations occurs due to the elastic forces, which means it is due to the restoring forces and inertia of the system. In this motion of the particle or the spring mass system, or for any free oscillation, the natural frequency of a system, in this case particle system, and constant amplitude, energy and period is observed, which means it is a motion which has a constant amplitude, energy and then period. Now it is very obvious that such thing cannot happen in the real case because of atmospheric drag present. In ideal cases, for example, as I told, if you assume that the spring is placed on a frictionless surface, and then assuming that there is no air present, in such case the amplitude, the energy and the time period of this would remain a constant. Examples of these free oscillations are when a stretched string is plucked. Example, think of a string on a sonometer. Example, think of sonometer. it will have a wire passing through a weight like this. In this case, if you fix it at this point here, by some means, and it is under tension, if you plug it somewhere here, if you pull it, or if you keep a tuning fork, or by some means if the wire is excited, then it will execute free oscillations. But again, here it's only an ideal case where using that tension will be 0 and atmospheric drag is not present. One example is when a tuning fork is struck against a rubber pad as given here. It's struck against a rubber band and led to oscillate. Even this would execute free oscillations. So basically, free oscillations are those in which the body will oscillate without any external force. A graph of displacement versus time would be as shown here. As seen in the graph, the particle has the same amplitude everywhere, which means it has not lost energy. So such kind of motion is called as a free oscillation. That is, amplitude after every cycle remains the same.